In this video, we're going to secure an Arch Linux machine for remote access using SSH. We'll take a basic system, scan for open ports, enable SSH, lock it to a custom port, and harden the connection using public key authentication, all while keeping the firewall type. This is a beginner-friendly project that teaches core skills in service management, port security, and remote login control, essential for anyone in cybersecurity. First, we install Nmap, a powerful network scanner. It lets us check which ports are exposed, useful for verifying that SSH is hidden until we explicitly enable it. With Nmap installed, we scan all 65,535 TCP ports on localhost. At this stage, no services should be running, especially not SSH. The results confirm that all ports are closed. Perfect. This gives us a clean baseline before we start enabling anything. Now we check if the SSH daemon is running. On Arch, it's installed by default but not enabled. The output shows it's inactive, which is expected on a fresh install. We now enable and start the SSH service. Then we run Nmap again. This time, we should see port 22 open. Port 22 is now visible. SSH is running and reachable. This shows the active, uncommented lines in the SSH configuration file. We'll now modify this file to change the default port. We change the default SSH port from 22 to 2222. This is a basic form of security through obscurity that helps reduce automated attacks. We restart the SSH service so the new port change takes effect. At this point, we tried to open port 2222 in the firewall but encountered an error. That's because UFW isn't enabled yet on this system. First, we enable UFW, the uncomplicated firewall. Then we retry the command to allow traffic on port 2222. This time it succeeds. Let's try connecting to port 2222. It now prompts for our password, proof the new port is working. We'll switch to key-based auth next. We generate a new ED25519 SSH key with a descriptive comment. This improves security and enables passwordless login. We use copy it to install our public key on the remote host. This makes future logins passwordless and secure. One final login test. This time, no password is needed. SSH is now hardened and secured with key-based authentication. Finally, we verify the SSH service is running smoothly and enabled. This confirms our hardening steps did not disrupt the service. We check the firewall status to ensure UFW is active, logging is on, and the correct ports are allowed. That completes the SSH hardening process. We've secured SSH by changing the port, disabling root and password logins, setting up key-based authentication, and configuring the firewall correctly. With these steps, your system's remote access is much safer from unauthorized attempts. Thanks for watching, stay secure.